This is a regular polygon. We're going to talk about the area of regular polygons and of composites today. Parts of a regular polygon that you need to know is you need to know what an apothem is, and that is this new thing right there. We label it little a. The apothem is a line segment drawn from the center of the polygon perpendicular to a side. This over here is not an apothem. It is a radius. But you could imagine that this little segment would cut this side in half. You see what I'm saying? There would be a lot of different ways that you could figure out things on this triangle because it's a right triangle depended on what you were given. Now today we're only going to do basically the formula, which is the apothem times the perimeter divided by 2. I really just prefer you do this. Apothem times perimeter and then divide by 2. Since all sides of a regular polygon are equal, you find the perimeter by multiplying the side length by the number of sides. Okay, so the perimeter is the P part. That's your distance around the outside. The little a is your apothem. Okay, and that thing is the distance from the center perpendicular to a side. Let's try it. So we've got an apothem. That's going to be your A of 7.5 meters. What is the perimeter? Well, you say, well, this figure is a regular pentagon. It has 5 sides. So to find the perimeter, we do 5 times 10.9. If you type that on your calculator or do it in your head, it is 54.5 meters. Meters. Then you do the area. The area is half the apothem times the perimeter, or do the apothem, 7.5, times the perimeter, 54.5, and divide by 2. So let's go ahead and type that in. 7.5 times 54.5 divided by 2. Got 204.375, which if we went into the nearest tenth, since it says tenth, 204.4 square meters. Number 2, the apothem is this value. It told us right here that it's 12, so I don't know why we have to write it in this blank, but if you can't do that, that would be quite the shame. 12 inches. The perimeter, the sides are 10. So going around the outside, if we were adding up all these sides, there are 8 sides. So we're going to do the shortcut. Instead of adding 10 8 times, we're going to do 8 times 10 and get 80 inches for the perimeter. All right, then we do the area. We take the apothem 12 times the perimeter 80 and divide by 2. That's 480 square inches. Okay. Now we're going to go over to the other side and we're going to talk about composite figures. A composite figure, well, if I could just write, it would be nice, but mine's a mess. A composite figure is a figure that can be separated into regions that are basic figures. To find the area of a composite figure, you separate the figure into basic figures of which we can find the area using the formulas that we have been given. The sum or difference of the areas of the basic figures is the area of the figure. Sometimes you add, sometimes you subtract, depending on the diagram. Find the area of each figure and round to the nearest tenth if necessary. If you like to use highlighters, that might be helpful here. What 2 shapes do you see here? Half a circle and a rectangle. Perfect. Okay, so I'm going to highlight out my rectangle. And I'm going to create a plan to find the area by drawing the pictures separately. You don't have to do this, but I think it's helpful for learning it. 15 would be on this left side, 34 at the top. So the area of this rectangle is base times height. I just wrote the formula on the figure, and now I'm going to write it down here. It'd be 15 times 34. And we'll go ahead and figure that out. 15 times 34, please. 510. Thank you. All right, so I got 510 square feet for the area of the rectangular part. Now, the other part, Olivia said was half a circle. And that's correct. It isn't a whole circle. That I have to add on. So it is half of a circle. But we're going to need to know how to do the area of it. The area of a circle is pi r squared. But that's not a whole circle. So what would I need to do? We've got the formula for an entire circle. Divide it by 2. All right, cut it in half. We're not going to give you, well, there is one problem on the homework that's not just a half, it's 3/4, but anyway. What is the radius of that circle, half circle? Okay, this would be 7.5 because you would take half of 15. All right, so that's your radius. So now we're going to do pi times 7.5 squared, and then we're going to divide that by 2 because it's half a circle. Now, I purposely wrote the division symbol by 2 instead of putting a bar under it because I didn't want you to confuse it with a formula that's not given. We don't have a formula for half a circle. We have to use our formula we know for a full circle and then logically divide it by 2. So have we calculated that? Pi times 7.5 squared. And that would be the area of the full circle. So then we hit divide by 2. And now we have the part that we have, which is 88.4. Okay, next step, add the two areas and have a final answer. So the total area would be 598.4 square feet. Okay, I hope that wasn't too bad. All right, so what have I got in the next diagram? What shapes do you see? A triangle and a rectangle. All right, let's do the hard part first this time. The triangle. It's not really hard, but I'm going to draw that triangle right over here. And then I'm going to add onto it a rectangle. Okay, and so I'm going to just write the dimensions on them. The rectangle is super easy. It's a 10 by 5. Area is base times height. So the area of that one's going to be 10. I know I couldn't stop myself from doing the easy one first, right? 10 times 5 would be 50 square units. Okay. So we already did the rectangle part. Get it over with. Now the triangle I have to figure out and label. So if there's a 5 way down here, there's a 5 here because opposite sides of a rectangle are congruent. So the base of the triangle is 5. What's the height of it? 8. How do we get 8? Yeah, since that's 10, you do 18 minus 10 and you get 8 for the height. All right. The triangle's area is base times height divided by 2. You can look up that formula. So now I'm going to take the base 5 times the height 8 and divide by 2. That's 40 divided by 2, so the area of the triangle is 20 square units. We add it all up and we get 70 square units for the area of the composite figure. Now I think I gave you plenty of space that you could draw these pictures and write things out neatly. Okay, now let's go to 3. Well, I need some ideas. This has got a hole in it. So, yep, we're going to need to subtract. All right, so you might, maybe you've had pencil grips before. Ever seen a triangular pencil grip? This would be like looking down at the top, except it'd be a little thicker over here, right? So it's got a circle cut out of it, so a pencil fits inside there. There's a lot of stuff in manufacturing that uses all this geometry. Tons and tons of it. So let's check it out. Let's draw a triangle. And you said we're going to have to subtract, I heard. And we're going to subtract out the circle because there's a hole. All right, so that's a pictorial of what, or an explanation of what we're going to do. The base of the triangle is 10. And what's the height of the triangle? That's the 7. Okay, now it says that the radius of the circle is 2.8. So I'll put that on my circle. Area of a circle is pi r squared. Area of a triangle is base times height divided by 2. I just jotted the formulas down. Now I'm going to use them. So the area for the triangle will be 10 times 7 divided by 2. Let's figure that out. That's 70 divided by 2, which is 35. We're going to have to subtract the area of the circle, so let's continue with finding that. It is an entire circle, so we do not divide by 2. We just do area is pi times 2.8 squared on our calculator. I need to grab the calculator. Pi times 2.8 squared is 24.6. All right, so we're going to subtract that from 35 and get our total area. What is that? 10.4, okay, and that'd be in square units. I would like the label, even though it didn't give a formal label. Okay, well, any skateboarders in here? Go to the skate park, though, maybe just hang out and watch some of them. If you don't do it yourself, I hope you get what my point is from this picture. Skating. Okay, that's just what that makes me think of, like a pipe. All right. So there's a missing piece to the shape. What is the missing piece? It's what shape, though? Okay, so we need to do a square minus how much? Oop, it's a half pipe. Half a circle. That's what we're doing. Okay, so we've got to do square, simple, simple. 8 times 8. 64. You should know that very quickly. Base times height. The circle part, pi r squared, but it's only half a circle, so we're going to need to take pi r squared and divide it by 2 for half a circle. Okay, so we got to figure out the radius of that circle. What is the distance from here to here? Okay, 4. All right, so we're going to do pi times 4 squared divided by 2. Pi times 4 squared. You have your pass divided by 2. Thank you. 25.1. Okay, and now to subtract them. 64 minus 25.1. 48.9 square. Oh, 38.9 square inches. Oops, I was off. Sorry, I did it in my head. I shouldn't have done that. Okay, 38.9 square inches. It's really hopefully not that bad if we've been understanding how to use the formulas for the basic figures. Right, let's go to the packet, please. There I go. Okay, this is just the start again of parts of the regular polygon. The perimeter is the distance around the outside. This is the front of your packet for today. By the way, there's an extra page in the packet I'll talk to you about. I didn't want them to rerun it. They ran it incorrectly in the copy room. So I will tell you that that packet looks way bigger than it really is. Hopefully that won't happen the next time I teach this. Anyway, here's your apothem, little a, and then you take that times the perimeter and divide by 2. You can always do the perimeter of the figure by multiplying the length of a side times the number of sides. All right, so let's go for number 1. Apothem, it says, is 4 meters. The perimeter would be 14 times 3, or 3 times 14, which is 42 meters. So now you follow the area formula. You take the apothem, 4 times the perimeter, 42, and divide by 2. 84 square meters. And you're done. I hope you're finding that quite simple. Number 2. This time, this thing has how many sides? Yeah, there's 5 sides. It's a pentagon. The apothem is given to be 6.9 inches. That would be right here. The perimeter is 10 sides of 5, so it's 10 times 5, or 50 inches. The area is 6.9 times 50 divided by 2. Okay, so we just use our calculator. I know somebody might have seen a shortcut to something you could have typed. 6.9 times 25. You should be just getting 172.5 square inches. All right. Number 3. Ideas. They didn't tell me the apothem. I got to figure it out. Okay, guys, this is a regular polygon. I got to get your thinking caps on. I know you're tired, or it's the end of the day, but what would this do to the 15? Bisect it. Good wording. What is half of 15? Okay, so that'd be 7.5. Now, what kind of triangle would this be? Since this is a regular polygon, it's a square. So it'd be a 45, 45, 90. If that's 7.5, what's this? Also 7.5. It would be this thing, the radius, that would be 7.5 times the square root of 2. So it's not that big a deal. You don't have to worry about that because we don't need it. Now, I hope somebody's seen something about this problem then. I hope you might have noticed something. Has anybody seen a simpler way to get the area of this thing? Apothem's half of... It's not. It's not, actually, because this would be a radius, and this is 7.5 root 2. So it's half of a side. I was looking for something else, but I'll tell you in a minute. First, let's do the formula. You got 4 sides of 15. So what's 4 times 15? Should get 60, right? Okay, now, let's do the area. Apothem, 7.5 times 60 divided by 2. Find that, please. Did you get 225? Okay, guys, now here's what I'm going to shake you up on, because this thing is a square. There was a much simpler way to do the problem. Yes, it's 15 times 15, and that's 225. It's a square. Sorry. But at least I proved it, that this works and gives you the same answer. as doing base times height. Okay. Oh, this is how I would do it though if I was doing a unit test or if I was doing a final exam. I would probably go for 15 times 15 over half the apothem times the perimeter. All right, moving on. All right, number 4. We're going to find the perimeter by adding up all the sides, and then we got to do the apothem. Oh, they told me apothem is 5 root 3, so what? 5 times the square root of 3 centimeters. The perimeter, sides are 10, and there's 6 of them. 6 times 10, 60 centimeters. We want to just be careful typing this on our calculator because we have to do 5 root 3 times 60 divided by 2. And what I mean by being careful, especially if you have these new operating systems, newer calculators, or you're using the ones that I let you borrow in class, 5 root 3, this system makes us have to get out of the radical. So you can't hit just times. You have to get out of there with an arrow, and then hit times 60, and then divide it by 2. All right, got 259.8. And units are square centimeters. Centimeters squared, you guys always think. 5. Apothem, 11.5. Base, you got 10 down here. They're going to do the perimeter. Do you want to know why it's half the apothem times the perimeter? No. That triangle would be base times height divided by 2, and there's that's why. That's why that's the formula. Okay, so I just had to tell you because I thought some of you might actually find that interesting. All right, so anyway, our apothem is 11.5 inches. Our perimeter would be 8 times 10, which would be 80. And then we just go for 11.5 times 80 divided by 2. All right, don't confuse the multiplying of these numbers with the adding of the bases when you do the trapezoid formula. 460 square inches. I did that right? Okay. Composites. Now we get to do those multi-figures. Composite figure that is separated into regions that are basic figures. You might do the sum and you might do the difference. Depends on what you've got. Let's try it. Number 1. This reminds me of a racetrack. What's the shape on a racetrack? Well, it's kind of like this. So what's that? But what can I do to make it put together? What's in the middle of of your track out there in school? The stadium. What's this part? It's the field, right? All right, and then there's the track around it. All right, so I'm just making it apply to something that you've seen. So let's do this rectangle first. So we're going to do a rectangle plus a what? Why is it a whole circle? Because it's a half on one end and a half on the other. And if you smush them together and you kind of went whoosh, and make a circle. All right, so let's talk about the dimensions of the two figures. This is 30 by 15 for this rectangle. So let's quick get the answer to that. That'll be 450 square centimeters. You with me? I multiplied by 15 by 30, or 30 by 15, doesn't matter. What's the radius of the circle? Half of 15, yep, 7.5. We need a whole circle. The area is pi r squared. So we're going to do pi times 7.5 squared. And then we're going to put them together. Okay, pi times 7.5 squared 176.7. So you could have just done 15 times 30 plus pi times 7.5 squared, and you would get the total, which is actually 450 plus 176.7. What's our total area, please? 626.7 square centimeters. Thanks. Okay, number 2. I see a triangle and a square. If those slashes are there, then this is a 22 by 22 square. If you want to draw them separately, I'm certainly encourage that if that helps you. If you don't want to, you can just do them and then put them together. I've just found that doing it this way has helped some students understand this better. Okay, if I got 22 there, remember all of these double slash sides are 22. But all I got to do the area of the square is 22 times 22, or 22 squared. So 22 times 22 is 484. Yes? Okay, so that's the square part. Now, I just labeled all of those slash sides with 22 on purpose, so I'll see that the base is 22 of the triangle. Now, I need to know the height. Okay, so where are we going to get that from? Right, if this is 22, then there'd be 20 more to get the 42 total. Okay, that's 20. All right, so triangle's area is base times height divided by 2. So the area of this triangle is 22 times 20 divided by 2. That would be 220. Now, our full answer isn't done until we put them together. So the total area is 484 plus 220. 704. And that would be in square centimeters. Okay. Number 3. Ooh, what are those shapes? What? Trapezoids, yeah. All right, so you go look up your trapezoid formula. Area of a trapezoid is base 1 plus base 2 divided by 2 and then multiply by the height. Or some say half the height times the sum of the bases. Okay, I got to find, I need the height of the trapezoid. So I'm doing a trapezoid, bless you, plus a trapezoid. Well, they're identical to one another. Their bases are 20 and 40. How big are the heights? Are you getting 32? Half of the 64. I heard you, so you're right. That'd be 32. Okay, let's do the formula. We'll do one of them, and then we'll just double it, right? So, bases 20 and 40. You add them. You multiply by 32, and you cut something in half at some point. But anyway, let's do it where we do the bases added. 60 divided by 2. 30 times 22. 32. 30 times 32 would be 960. Now that's for one of them. So you get 960 plus 960. So the full area is, all right, 1920 square meters. Okay. Number 4, we've got two triangles. I think this is my last example before the assignment. Let's find out how tall the triangles are. Well, that's 15, so it's cut in half. All right, 7.5 apiece. All right, area of the triangle equals base times height divided by 2. So the base is 35, the height is 7.5, and then we divide by 2. So let's get the area of one of them. All right, so that's, I don't know, 35 times 7.5 divided by 2. I think it's bigger than that. 131.25. Okay, now that's the area for one. So we have another 131.25 for the second one. So we got to double that. So the area for total, the total area would be 262.5 square yards. You all understand what I did. I did one triangle's area. I doubled it because they were the same. Area of one triangle plus area of the other triangle. All right, now on the homework, there's a couple of challenging ones. What's this look like to you? It looks like ice cream cone, doesn't it? Or slushy. Yeah, sideways. Somebody dropped it. Anyway, at least the ice cream didn't fall out. But hey, hopefully when they give you a scoop, it goes like this, right? That you get the whole scoop. This is only half a scoop, guys. The scoop is not, I'm just making a point that you will not include a whole circle. How much of a circle is here? All right, half. So don't do a whole circle. I will help with any of these while you work on this. I think you'll want to ask me maybe a couple or just want to check the answers. So let's get going. Yeah, 2 is probably the first one I would say you were going to ask me. Okay. I'll do it in just a second. Yeah, I don't know why I'm doing this. All right. Well, first of all, let's do the area, the easy part. 2 times 2, 4. All right, so we got that. Now what? How much of a circle do you have there? That was 90. What's that angle? Mm-hmm. 270. So that's 3, or you could realize that that's a quarter missing. Quarter, quarter, quarter would be 3/4 of a circle, or half a circle plus a quarter. It's 3/4 of a circle. However, this would work. Let's do 270 out of 360 times pi times the radius squared, pi r squared. That's the area of that part. Why? Well, it's only part of a circle. It's 3/4 of the circle. So I just chose to do it like a sector. That chunk. Anyway, so that's what we're finding now. And that would be its area right there. And then we're going to add to that 4 for the square part. All right. All you got to do is do this on your calculator and add 4. You shouldn't be having texting in class. Shouldn't be getting texts in class, but I'm just saying that I don't like that they're doing that. Was that Mr. Dredge then? We've been told not to follow group chat emails, period. So I guess I should check if it's in, I don't know. Am I still recording? Are we good with number 2? We're still okay. Okay, now, number 3, just, what are you going to do? Separate it into 2 whats? All right, did anybody think of closing it up? You can do that too. Or you can just separate it, like maybe right there. But then you got to figure out how big it is right here. That'd be 3. Take 6 minus 3 and you'd get 3. So now you could do the area of this chunk and this chunk. Okay? I am most often asked about number 4, so maybe we should go there. All right, let's do that so I can actually have recorded how to do this one. One of the displays at a botanical garden is a koi pond with a walkway around it, and the figure shows the dimensions of the pond and the walkway. Clearly, the pond must be this thing in the middle. It's a lot like our racetrack problem. It's not even close to time to go. So if you packed up, get your paper back out. That makes me mad. You've got half a circle on the end, on the left end, half a circle on the right end, and a rectangle in the middle. So if you're going to do the area of the pond, that is 13 by 7. Plus, what would you be doing the area of for the rest of it? The rest of the pond. It's not just a rectangle. A full circle, right? Put together a half plus a half. So it's going to be plus a full circle. Thanks, Chloe. All right, then we want the radius of that circle. Its diameter is 7, so its radius is 3.5. Okay. 13 times 7 is the area of the first part. That's the easy part. What? Oh, that would be 91. Agreed? 70 plus 21, 91. I think I did that right in my head. All right, now, the circle area is pi times the radius squared. So we're going to add on pi times 3.5 squared. Let's get that total area, please. Pi times 3.1 squared. No, it was 3. Oh, I did it again. I hit that wrong button. Second, pi times 3.5 squared. Okay, and then I needed to add to that 91. And now I got the whole pond, 129.5. All right, that would be in square feet. All right, this is your pond. Now, the area of the walkway we want to know. So what we're going to have to do is think of this, guys. You see all that? This is the walkway. So what are we going to need to do? We're going to do the whole thing minus the pond. Okay? So let's do the whole thing, which would be a rectangle, which is 35 by 15, plus a circle, which is a radius of half of 15. Yep, 7.5. All right, once I do that, I got to take out the pond, minus the pond. All right, so I do 35 times 15, plus I do pi times 7.5 squared, and then I subtract the pond, 129.5. What's 35 times 15, please? All right, so here's your calculation. 525 plus pi times 7.5 squared minus 129.5. I'm going to finish that problem. Whoops. You stay right where you are. I am tired of lining up. Okay, there's the circle part. Oh, we did that one before. All right, add them all up together.